Tell you what we'll do for a laugh, let's short out the secondary of the transformer and see if we get a spark. Oh, not a sausage. Bum holes. Okay, I think we've got a transformer here that's got an open circuit secondary for the high tension, which unfortunately means that we've probably got absolutely no point in going any further, because this is something which isn't going to be easily repairable. I'm certainly not going to start rewinding a transformer for this, for the simple reason that I don't care about it that much. Even if we get it up and running, it's not going to be a super duper signal generator anyway. So I think what we'll probably have to do with this is it'll probably go back in the junk pile until we can find another of these units to cannibalise for a transformer. Before we do condemn it though, let me just disconnect this wiring. I'll need to trace it back. I want to make sure that I have actually got some windings coming from the transformer, because it's not impossible that I've made a mistake. And I guess the other thing is it's very unlikely, but could one of these wires be broken along here? And again, it's not really easy to trace out because of course everything is just yellow. All the wiring is yellow. It kind of makes you wonder how they actually wired this thing up originally, doesn't it? You know, they made it hard for themselves. I certainly wouldn't like to wire something up. You know, this yellow wire goes to here and that yellow wire goes to there. Maybe when you've built 500 or 600 of these it becomes second nature, but you know, why didn't they use some different coloured wires? Now we've seen what we've seen, I'm not going to be so gentle. I'm just going to cut the other wire off the secondary of the transformer, because I think it's probably not going back on. And we're also going to have to disturb this lovely looming. Somebody took some time here. Well, again, all done by hand. Some guy sat in his little workshop here when these things were built, and he got some kind of wax covered cotton string. He bunched all the wiring up together and tied it, and yeah, I'm now just going to cut it away after it's been so nicely tied for the last, I don't know, the last 70 years or so. I kind of hope I've got it wrong and these wires end up not going to the transformer, because if they go somewhere else, that might be explaining why we're not getting any AC on them, but I don't think we're that lucky, to be honest. Alright, and I can actually see the way they've twisted these wires together. They've actually paired them together, which I guess is an immunity thing, an EMC thing, that they've twisted them together. Oh! Could we have got lucky? Could that be the problem? The wire's just fallen off the transformer. Oh, shall we see? Have we got lucky? Have we got lucky? I'm not that lucky. I'm an unlucky bugger. That won't be it. But let's solder it back on. Let's solder it back on. You never know. You never can tell. I would have thought we should see a few hundred ohms across the secondary of the transformer. Come on, come on, come on. See some resistance. No. No, you see, we're seeing on the meter here, we're seeing lots and lots of megs. Let me just test my meter of 0.4 ohms. We're getting 17 meg ohms. So unfortunately, the secondary, one of the secondaries on our transformer here has gone open circuit, and that is not repairable by me. So these transformers are covered in a lot of varnish, and the reason that they did that is because they actually shipped them all over the world. These Avos were probably shipped to a lot of the armed services and, you know, a lot of diplomatic services and, you know, a lot of the ex-British colonies, and you know, some of them were hot and humid places. So these were manufactured to very exacting levels. I'm not sure how well this is coming up on camera, but now I've actually bothered to scrape away some of the varnish on here. I can see that the windings are very discoloured, very burnt looking, so I'm fairly sure at some point in the past this transformer has got very, very hot, and one of the secondaries has shorted out. Actually, it's not shorted out anymore, it's actually burnt out, and luckily it went open circuit. Now of course it's impossible to tell if that happened when somebody destroyed the input attenuator. It's quite possible that, you know, the same thing that burnt out the attenuator also resulted in burning out this secondary of this transformer. I guess we'll never know. Now I'm afraid this is terminal, there's nothing more I can do about this. It just isn't economical or worth my time to try to rewind this. Well, I'm afraid there's nothing I can do with that, so it's snippy snippy snip time. Now you know what, I'm not exactly sure what the high voltage supply should be for this. Just looking at this smoothing capacitor, what does it say? Looks like it should have been 350 volts. So 350 volts, well, I'm kind of guessing that it was probably around 250 or something like that. It's 350 sounds much too high, so I'm going to go for 250. Now at the moment I'm powering up the signal generator via my isolation transformer, and we're up at the full mains 230 volts here, so you can see that the dial lamp has fully illuminated, but I haven't actually switched on our DC supply yet. We can actually see now that the dial is illuminated, and you can see that the scale you're on, the section is you know, clearly lit up. If you actually just change it to a different range, can you see that moves up? So it makes it really very, very clear to see which actual frequency band you're set to. I think that's a really nice feature of this. Okay, I think we got a bit of something then. This thing is trying to oscillate. It is trying. Come on, baby, you can do it. And it's even roughly in calibration. So I've got the dial set to 100 kilohertz and it's actually coming in at 96, so it's a little bit out, but I don't think we can blame it for that. I'm not even sure if I've got the correct HT voltage for this thing, I'm completely guessing. But you can see it is actually trying to work. So I think there is some hope for this unit if we could just get a replacement transformer for it. Now if we do turn the frequency up a bit, we tend to lose the oscillation. Let me just go up to the next range. Yeah, and we've lost it. Oh, we got it back. So let's see what the calibration's like on this one. So this should be around 300 kilohertz, and it's coming up as 295 kilohertz. Fortunately, there's something not quite right with the oscillator. It doesn't appear to have enough positive feedback or phase shift to keep oscillating. So what I'm doing is occasionally, as I turn the frequency up, it will stop oscillating as it has done there, and it won't automatically restart, but if basically I just give it a bit of a flick, I can actually kick the oscillator valve back into action. You know, this is a sick puppy. It probably needs new capacitors and new resistors, and I'm not even sure I've got the high tension, the B plus voltage correct for this, but we can really see this thing is actually trying to operate. It really is trying. So we just need a new mains transformer, and I'm sure we could actually restore this and get it working really well. So this is a coil box assembly, and you can see we've got a little valve in it here, and this little valve is what's responsible for all the, you know, the high frequency oscillation of the signal generator. And then we've got a bigger valve on the outside and a transformer. Well, this transformer here, it's not actually a mains transformer. This is what they call a modulation transformer. So this valve is actually set to oscillate at a much lower frequency, and I think it's about 1 kilohertz. Well, as it turns out, I think I made a mistake with the voltage that I was feeding into the signal generator. I think I said it should be about 90 volts, but I actually looked up the wrong valve, and I think the actual valve specifies a typical voltage around 200, and we were only supplying 90 volts to the unit, so it's maybe not surprising it didn't work properly. So I've gone ahead and I've got out this power supply, which I like to call the power supply of dubious electrical safety. So here it is. What could possibly go wrong with putting more voltage up it? So unfortunately this power supply only has a 300 volt DC output. There is actually another module that's designed to clip onto this side, but I don't have that to hand for some other reason. It's got lost in the hoard. So I'm going to turn the power down a little bit, turn the voltage down using the Variac. Well, I have to say I'm actually getting quite scared now. This setup does actually live up to its dubious reputation of electrical safety. Now unfortunately at this stage we really just are in it for the giggles. This really isn't going to be very easy to repair, and to be honest I really can't be bothered buying or putting another transformer in it. So let's just put 200 volts up its bum and see if that wakes it up. Be nice to get the low frequency oscillator working. So I did actually find some of the resistor values in the low frequency oscillator here. They were kind of well out, so I have gone away and I've just replaced these. Output. It should be working I think now, shouldn't it? Oh, turn the plug on. Okay, there's 100 volts, that's about where we were before. Now I decided to do some testing at a higher voltage, about 150 volts, which I actually still think that probably would have been okay. Anyway, I was doing that testing and something decided to let the magic smoke out, and whatever it was inside this coil box, and it's actually very hard to get at. So I have took off the turret tuner, and I thought I would show you that. I think the reason that we have these turret tuners is that generally it was to reduce the capacitance and the inductance of the winding. So rather than kind of having lots of wires running around to all these various inductors, you know, from a centre switch, what they actually do is they mount all the inductors effectively on the switch like this, and then this switch rotates. And you can see it's got this series of contacts, and this series of contacts brushes against these contacts on here. So that's how we, you know, that's how these various inductors get pulled into circuit. They used to sometimes put things like this, these turret tuners. They're probably more famous for being on TVs and stuff. But as I say, the main reason it was to reduce the capacitance and the inductance of the wiring that would normally go to a centre switch. So I've gone ahead and I've removed that, because whatever would let the smoke out was in here somewhere, or so I thought. I wasn't sure where it had come from actually, what had let the smoke out. So I've been tracing the voltage through, and I found out that the voltage drops inside this coil box here. And what I've done is I've come to this capacitor, and if we just measure the resistance of this capacitor, if I can show it you, and the resistance of this capacitor is around 380 ohms, which of course isn't correct. We shouldn't have a reading of 380 ohms, we should have a pretty much infinity reading. So we really need to find out what's gone on here. Unfortunately, I'm not exactly sure which this capacitor is, and everything really is quite hard to get at. Unfortunately, I can't pull this off. It's actually got some resistors actually holding this PCB board down, so it's pretty much impossible to get in here. I don't know, cut this off and think of some way of bodging it back together. I'll cut it off if I can get in here anyway. I'm actually about to call it on this piece of equipment. It reaches a point where, you know, if you don't really want to spend the time working on something, it just becomes a, you know, a diminishing return. In fact, I don't even think I can get at that. I'm struggling to read what value it is as well. And yep, it's definitely coming up as 396 ohms, so that is not correct. So this 820 picofarad capacitor, I don't think it's actually doing anything particularly exciting. It actually looks as though it's in the filament supply, so I think it's actually here along with this inductor. It's there to stop any RF noise leaking out of the coil box into the rest of the outside world and making the whole thing live with RF. So this thing will probably run without it. It's surprising that that has failed though, because I'm reading that right. It shouldn't have that much voltage on it, that capacitor. It should only have about, I don't know, it should only have a few volts on it. That is there another capacitor, another small one? It's the only one I can see that's 820 picofarad. Well, I've got to admit, I've found myself getting quite annoyed with this little job and losing patience with it. And I think it's probably because I don't have an end game for this thing. I mean, it's clearly stuff. We aren't going to be able to fix it because the the transformer's knackered, so I was just having a bit of a play with it for my own entertainment, really just to figure out what else was wrong with it. And as it turns out, there does seem to be quite a lot wrong with it. I have been talking to a few people about this, and most people have said that these are actually very, very reliable, and you know, they tend not to have many problems. Well, unfortunately, this doesn't seem to be the case. It seems to have lots of problems. Not that I'm really complaining, because at the end of the day we did only pay £5 for it, but sometimes you've got to just temper your enthusiasm for these things. I've only got so many hours in the day, and you know, I don't want to spend an infinite amount of time fixing a signal generator, which, well, I've got to admit, I quite like its kind of Art Deco design, but I've got lots of signal generators, all of which are orders of magnitude better and more reliable than this one. So I don't have a huge reason to get it going, apart from the interest, and I am semi-interested in that. So I've gone ahead and I have just, you could probably see I've just bodged in another capacitor. I didn't have a value that was 820. I've put the nearest value that I did have, which was, as a matter of fact, that was only around, well, it was around 1,000, so I've gone from 820 to 1,000, and you know, it's got that in because that's all I've got in that value. But we have gone ahead and cleaned the contacts up, and I'm just hoping that we can get this thing to oscillate again. So it does look as though we've got it working now on all ranges again, perhaps. Let's double check that. So auto set, so that should be set to about, what's that? I think that's the 50 range. 50 to 150, so that should be around 100. And that's 97. So that range is now working. The next one is 300. And we're on 393, so that's not bad. Next range. I think that should be a megahertz. And it's 988, so it's in the ballpark. So it's like the switches are a bit dirty, or they're not quite indexing as they should. I think that should be 3 meg measure, and that's 3 meg, flicking between 2.9 and 3 meg. And that's coming up 10.99 meg. Final range is a 40 meg range, so let's just adjust that one. And again about 40 meg, so it is now working now. Right, I'm going to call that a success anyway. Let's try our modulation valve back in now. If we can get some low frequency modulation, it's definitely winner winner chicken dinner. Looks like I haven't quite managed to get the modulation working on this. Previously I'd been getting some very unreliable operation of the high frequency oscillator in here, and eventually, after a lot of messing around, I've traced it to this inductor, and I think the purpose of this inductor is probably to stop RF energy getting back into the low frequency oscillator and upsetting it. It's probably something like that, and it has a very, very fine winding on it, and the link wire was very loose, and I wouldn't say it was broken, but it was kind of cracked. So what I've actually done is I unsoldered that, and as I unsoldered it, it actually just fell apart, the wire. So I've just soldered in a new piece of link wire, but I think it's probably very vulnerable to while I'm working on this thing. So I've just gone ahead and I'm going to get a candle and I'm just going to try to melt a bit more wax onto here just to actually stop it all coming loose. Although you probably wouldn't think it, candle wax actually tends to do a really excellent job of cleaning up your soldering iron tip, although it is very smoky. Incredibly smoky. So I've just spent a few minutes poking around with our low frequency oscillator. I think I said earlier that this thing is designed to operate about a kilohertz, but I think I was wrong because I read the manual and it says it's designed to oscillate around 400 hertz, so that's really quite a low frequency. So I've taken some voltage measurements, and one thing that I did think was a little bit odd, we've got about 1.5 volts on the, I'm going to say the plate, on the grid. I was going to say gate, then I was going to say plate. I'm going to go for grid. Let's try again. So we've got 1.5 volts on the grid of this L63 valve here, which is our oscillator valve. I think I've said in previous videos, if you ever see a positive voltage on the grid of a valve, that tends to be a bad sign. So I'm guessing that we are getting some voltage leaking in through this 0.05 microfarad capacitor. I said if we're getting some voltage leaking into there, I would expect that this valve is conducting quite heavily. But the problem with that is we've got this cathode bypass resistor here, and if I measure the voltage across the cathode bypass resistor, we've only got 8 volts on it, and I wouldn't expect that. So that means that we've probably got, 200 odd volts up here. So we've only got 8 volts across this cathode bypass resistor. This valve really isn't conducting very heavily, so I'm not really sure what's going on at the moment. I think what I will do is, because it's an old waxy capacitor, I'm just going to go ahead, I'm going to change out this 0.05 microfarad, then I'll give it another test, and then I'll see if we can change out this 0.02 microfarad, because they are old waxy types. And if it doesn't oscillate then, I guess it's just going to be a matter of maybe testing the valve. But I wouldn't expect this valve to have burnt out or worn out, because this signal generator, it's not like a valve radio that's going to have been on for hours and hours and hours. This thing has probably hardly been switched on throughout its life. So in things like a signal generator, I wouldn't expect a valve to be worn out as such. I wouldn't expect it to have gone low emission. But there's definitely some shenanigans going on here. So I've just gone ahead and I've cut out the grid coupling capacitor. And the value of this, it's, it's 50 nanofarads rated at 350 volts. So I'm just going to try it on the capacitance meter. And it is coming up as 46 nanofarads, so the capacitance value is correct, but the problem is, has it got some leakage? I suspect it may have, so I'm just going to go ahead and I'm going to replace that. I think these, I always get confused between polyester and polypropylene. Are these polyester? Anyway, I'm going to go ahead and replace it with this. This is rated at 400 volts, so it should be fine. Let me just double check it has got the right value. Oh, and it hasn't, so that's not right, is it? That's 100 nanofarads. So where's my 0.5s? I'm sure I've got some somewhere. My eyesight's a bit rubbish these days, so I do need to check these things. Let's try this one. Hopefully this will give us the correct answer, and I can edit that out. Nobody will ever know my mistake. Okay, 46.65 nanofarads. So let's go ahead and stick this in. And I intend to leave the legs on this capacitor pretty long, for the reason that if we end up scrapping this, these capacitors like 50p each or something, I will rip them out if we happen to scrap this. Which at the moment is quite likely because of our output transformer problem. Okay, so that's that capacitor changed. Shall we see if that's made any difference? I'm not really holding my breath, to be honest. So our valve grid is pin 5, which is that one. Okay, so we've got 0 volts on our valve grid now, which is something. That's that is what I would expect, 0 volts. So we've got rid of the leakage, so you could say that's a positive sign. Let's have a look at the cathode bypass resistor now. So that's got 7 volts on it, that hasn't changed. So let's see what we've got on the anode. So we've got about 170 volts on our anode, which is pretty much the full HT for this. So there's just looks like, again, this valve just isn't conducting and it's not oscillating. Now the only other capacitor we've got in circuit, we've got a 0.02 microfarad, which is actually across the transformer, across our modulation transformer, which is this one here. And again, I don't think that'll cause a problem. I don't think that's what we've got here, but let's go ahead and change that out, and we're going to give it the best chance we can of working. Snippy, snippy, snip, snip, snippy, snip, snip, snippy, 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 snip, 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 go on, snip, snip, yeah, get in there, quick, snip. Ah. Alright, so this one's actually rated a bit higher, that's 500 volts DC, so I'm guessing it perhaps sees a little bit of flyback from the transformer. Okay, so this one has gone a little bit high. It says it's 36 nanofarads, but I would have thought that that is within the tolerance for this capacitor. But I think we've got a 22 one here. .21 nanofarad, so that should be good enough. These actually are quite old capacitors, the legs on them are a little bit dirty, but we should get away with it. Okay, shall we give that a go? See if that, ooh, that wire's broke off there. These wires are actually just old and they've gone very brittle. The copper in them has worked hard and over the years it's just gone stiff. I've just stripped that off and soldered that back on. That one's actually the heater, the filament wire, and the valve has been glowing, so that isn't the problem, because you know, the valve's getting hot, so it's not this wire that's had a bad connection, but worth a thought, wasn't it? As I say, I just look at this as being temporary wiring. If we can get something working, we'll come back and we'll tidy all this. Okay then, boys and girls, place your bets. Let's switch it on and see if we've got any modulation. We should get about 400 Hz according to the manual, so are we ready? Easy wizzy, let's get busy. Oh, something bounced up and down then. Oh, pitting. We've got some oscillation. We've got, what is that? We've got 312 Hertz, so it's a little bit off frequency, but that is modulation. Bobby Dazzler. So it looks like our problem was this capacitor that's wired in parallel across the windings of the modulation transformer, and I'm kind of surprised at that, because although it was impossible for it to try to leak DC into the grid of our oscillator valve, it actually has got a blocking capacitor in front of it, and I wouldn't have thought it would be that sensitive, but we've changed it and now we have a working low frequency oscillator. So if we go back to the high frequency output on the signal generator, hopefully we should see the output being modulated by that waveform. So shall we have a peek? Sneaky peek, let's have a sneaky peek. Oh. So my scope really doesn't like this waveform, it doesn't know what to make of it. Oh, there is some modulation there. It's going to be difficult to show you on a digital scope, but there is some modulation occurring there. I think what we need to do is we need to break out an analogue scope. And I've got just a thing, because as it happens, I bought another oscilloscope on Sunday because, well, I only had 13 And according to Simon Spears, the ideal number of scopes to own is one more than you actually have. So today on the bench we've got this 50 MHz Philips PM3217, and these old Philips scopes, they are somewhat of a stalwart in the UK. A lot of television repair shops and things used to have them. I don't think I've ever actually owned one of these, but they were a popular scope, and this was going for £20. And how can you resist a scope at £20? It just had to come home with me, didn't it? Had to get a new home. Well, I'm hoping that that's going to come out on camera. So you can see we've got the actual low frequency output from the signal generator, and it's actually it's modulating the high frequency output here. Now there's not an awful lot of modulation on here. It's certainly not as much as I expected. I seem to think it might have said about 40% on them in the operating manual. Well, that's nowhere near 40% modulation. Well, really, I think we've done about as much as we can with this Avo wide range signal generator. We have proved that this instrument is capable of living again, but unfortunately that burnt out HT secondary is that really makes it a little bit terminal, and I'm really desperately hoping that you don't leave it in the comments that you want me to see me having a go at winding a new mains transformer, because life's too short. So I think until next time, as always, thanks very much for watching. I always appreciate it. I enjoy your comments, and I hope to see you again very soon. But until then, bye bye for now. Bye.